Hello everyone, Dr. Polaris here. Although the Triassic forms a part of the Mesozoic, it represents just the beginning of the so-called Age of Dinosaurs, with the great reptiles emerging during the second half of the period, and even then, with just one successful archosaur lineage among many. In a previous episode I covered the early evolution of the sauropodomorphs, which started out as small bipedal omnivores, before relatively quickly, and by quickly I mean about 20 million years, transitioning into large-bodied specialised herbivores such as Plateosaurus and Melanrosaurus, being among the most massive land animals of the Triassic, alongside the synapsid dicynodonts. While sauropodomorphs grew to fairly substantial sizes before the end of the period, the same cannot really be said for their theropod cousins. Indeed, while these animals are most well known for the massive apex predatory forms that emerged during the Jurassic and Cretaceous, older Triassic representatives of the clade were generally pretty modest in overall size, often playing second fiddle to the larger terrestrial pseudosuchians such as Postosuchus. Members of Theropoda can generally be defined by their possession of hollow bones, 5 or more sacral vertebrae, an enlarged carpal bone, and a well-developed ball and socket joint near their neck and head. Like the early sauropodomorphs, the second digit in theropod hands was often enlarged, while the feet showed a reduction in the overall number of toes, with digit 5 vanishing before the end of the Triassic, while digit 1 was often present as a small dew claw, leaving a distinctive foot wherein 3 major toes made contact with the ground. When I was growing up in the 1990s, I distinctly remember theropod evolution being presented as a simple transition from early basal forms like Eoraptor and Herrerasaurus to more derived coelophysoids and Dilophosaurus, although more recent evidence uncovered since then has shaken up this neat picture. Eoraptor is mostly no longer regarded as a theropod at all, being placed as a very basal sauropodomorph instead, while Herrerasaurids have proved far more difficult to classify due to their possession of a strange combination of anatomical traits. This family included roughly 4 or 5 genera of predatory strongly carnivorous forms that ranged between 2 and 6 meters long, with the largest members reaching up to 20 feet long and 750 pounds in weight. All of the most well-known forms native to what is now South America during the late Triassic, between 233 and 228 million years ago, although possible representatives such as Chindisaurus and Cassiasaurus were found in North America as well. Herrerasaurid anatomy was unusual and specialised, and they are not considered to be ancestral to any later dinosaur group. They probably only superficially resembled theropods, and often present a mixture of very primitive and derived traits, with some of the features that define dinosaurs as a whole being either absent or weakly developed, such as the partially open acetabulum in the pelvis, which in other dinosaurs is fully open, while the spine contains only 2 sacral vertebrae, a strangely low number. The structure of the skull in these animals was also quite blocky, with an overall rectangular shape, more closely resembling the condition found in more basal archosaurs such as Euparkeria, while the hands retain 5 distinct digits. Such a hodgepodge of anatomical traits has made Herrerasaurids very difficult to classify, with the whole host of different positions being recovered for this group over the years. While most older studies found them to be an unusual early group of theropods, more recently these predators have been placed as either basal sauropodomorphs, basal saurischians, or even outside of Dinosauria entirely. So as you can see, there is no overall consensus as to the relationships of Herrerasauridae, but nonetheless these were the first moderately large dinosaurian, or at least dinosaur-adjacent, carnivores of the Triassic. The type genus, Herrerasaurus itself, was also the largest known form, measuring up to 6 meters or about 20 feet long. Native to the Ischigualasto Formation of Argentina between 231 and 228 million years ago, it would have been a fairly lightly built, agile carnivore with strong hind limbs and long feet. The skull was relatively small in relation to the overall body size, being rather rectangular in shape, and possessing a flexible joint in the lower jaw that allowed for a grasping bite. This is an odd feature among carnivorous dinosaurs, but is relatively more common among lizards. The jaws were equipped with large serrated teeth for biting and tearing flesh, and the neck was slender and flexible. In addition, the forelimbs were quite elongated, particularly in comparison to more derived theropods. In life, Herrerasaurus would have been an adaptable predator that hunted a variety of smaller herbivores with which it shared its environment, including the rhynchosaurs, dicynodonts, and the mysterious possible silesaurid or ornithischian Pisanosaurus. It was not the top-order carnivore of the formation, however, with this honour going to the large Rauisuchian Saurasuchus, which seems to have preyed upon Herrerasaurus on occasion, as demonstrated by the deep puncture wounds found on a single skull of this animal. The more recently described genus Gnathovorax, from Carnian age deposits in Brazil, was generally similar but smaller, measuring about 3 metres or 10 feet long, and is represented by a fairly complete specimen, along with other early dinosaurs such as the sauropodomorphs Pampodromeus and Bureolestes. Gnathovorax did not possess a pneumatized skeleton or a system of invasive air sacs, suggesting that these features developed multiple times among archosaurs, including in pterosaurs, sauropodomorphs, and theropods. Some Herrerasaurids were smaller still, such as the very incomplete Styracosaurus, which probably measured about 2.2 metres or about 7 feet 3 inches long, and may have been the most basal member of the family. Overall, Herrerasaurids appear to have been quite successful during the Carnian stage of the late Triassic, but, the dubious genus Casiosaurus notwithstanding, seem to have vanished by around 228 million years ago, for reasons that are not well understood. A selection of additional carnivorous dinosaurs from the late Triassic have sometimes been recovered as Herrerasaurs as well, although their position varies greatly depending on the particular study. The genus Eodromaeus, for example, was hailed as the oldest known true theropod upon its discovery in 2011, although more recent analyses have increasingly cast doubt on this, finding it to have been either a more basal Saurischian or an early diverging Herrerasaur. The genus Tawa is in a similar state of limbo, named after the Puebloan sun god and native to what is now New Mexico about 215 million years ago. This slender animal is thought to have been roughly 2.5 metres or 8 feet 3 inches long, and weighed circa 33 pounds, possessing a more gracile build than earlier animals like Herrerasaurus. In fact, in some respects, Tawa represents a transitional form between older carnivorous dinosaurs and the more derived coelophysoids, with which it shared the Nourian-aged Ghost Ranch site. Its skull was relatively narrow and had a noticeable kink in the upper jaw between the maxilla and premaxilla, which was a typical trait of early theropods. It was also a fast runner, able to chase after relatively small prey, including the small lagurpatid Dromomeron. However, perhaps the oddest of the basal Triassic carnivorous dinosaurs was Daemonosaurus, from the latest Triassic Chinle formation. The holotype specimen of this genus mostly consists of a single well-preserved skull, along with some postcranial elements, and what a skull it was! With a short snout, comparatively large eyes and long slender teeth, it would have certainly been a distinctive-looking animal, especially compared to the long-snouted coelophysoids. Although known from very incomplete remains, the living genus may have measured about 1.5 metres or 5 feet long, and there have been suggestions that it may have been a juvenile, explaining some of its odd traits. On the other hand, the fusion of the neurocentral sutures in the vertebrae suggests a fully mature individual. Again, it is uncertain as to exactly what this animal was closely related to, with the most recent studies finding Daemonosaurus to be a non-Herrerasaurid Herrerasaur, and thus a basal Saurischian. Beyond these oddball genera, the first definitive theropods are all members of the clade Neotheropoda, which first appeared about 228 million years ago. The most basal, and not to mention the most widespread of these, were the coelophysoids, which possessed a near-global range by the end of the Triassic. While the type genus Coelophysis itself is a famous and well-known animal, helped immensely by its starring role in the first episode of Walking with Dinosaurs, there are actually about 11 genera in this group, many of which are far more obscure, and therefore I'm bound by law to cover them. Overall, members of this lineage tended to possess slender builds and elongated narrow skulls, and spanned a wide range of sizes, from just 1 metre or 3 feet long in the smallest species, to potentially up to 6 metres or 20 feet in the largest forms. The internal classification of coelophysoids is still being figured out, but the genus Liliensternus has recently been recovered as the most basal member of the group. Native to what is now Germany during the late Triassic, it seems to have been among the largest coelophysoids, potentially measuring up to 5.2 metres or 17 feet long, and weighing 441 pounds at a maximum. It is the most completely known Triassic theropod from Europe, and was once thought to have been a close relative of Dilophosaurus, often being restored with a similar prominent head crest. Although there is no direct evidence for this, it would have been a top-order carnivore in its environment, swiftly chasing down herbivorous sauropodomorphs such as the contemporary Plateosaurus, essentially presaging the development of more massive theropods of the Jurassic. Other basal coelophysoids included two genera from Wales in the UK, the older of which was the recently described Pendraig, that lived between 215 and 201 million years ago. It was among the smallest coelophysoids, measuring just 1 metre or 3 feet long, although the only known specimen was probably a subadult. During the late Triassic, the areas of southern Wales Pendraig lived in consisted of a series of islands made of carboniferous limestone that had been folded and pushed upwards. The environment would have been comprised of dry forests, described as being somewhat similar to the modern Cayman Islands in terms of climate. The younger genus, Dracoraptor, was found in very early Jurassic deposits that were between 201 and 199 million years old. It was larger than Pendraig, being potentially up to 3 metres or 10 feet long, and represents one of the oldest known non-avian dinosaurs recovered from the UK. At about the same time, the similar genus Panguraptor was present in what is now southern China, showing how far dinosaurs had spread out of their Triassic origins in South America. However, by far the most famous coelophysoid was the genus Coelophysis itself, known from a multitude of specimens recovered from the southwestern United States, particularly the Ghost Ranch Quarry of Arizona. Measuring about 3 metres or 10 feet long, this was a lightly built, fast-running predator that weighed about 55 pounds as an adult, possessing large forward-facing eyes and a narrow, slender snout. A 2004 study found that the vision of Coelophysis was superior to that of most lizards, and ranked with that of modern birds of prey. The data also suggested poor night vision, which would mean this dinosaur had a round pupil rather than a split pupil. Overall, the genus would have been an agile, visually oriented predator of small game, such as lizard-like rhynchocephalians, small cynodonts and hatchling pseudosutians. But, like modern coyotes, it could potentially have taken on larger prey if attacking in a mob, although coordinated pack hunting in Coelophysis is unlikely. Aggregations of dozens of individuals are known in the fossil record, but these probably represent the remains of animals that died in a drought or flash flood. Interestingly, the genus demonstrates highly variable growth patterns, with adult individuals spanning a wide range of sizes. This trait is also seen in Plateosaurus, but is rare in later, more derived dinosaurs, perhaps being an adaptation for surviving the harsh, dry conditions of the late Triassic. It was also a long-lived genus, persisting for about 7 million years, clearly being a successful animal, with many different species being assigned to it in the past. However, these have since been reclassified into their own unique genera, with these including the Zimbabwean Megapnosaurus, which had also previously been known as Syntarsus, representing one of the youngest known coelophysoids, living between 199 and 188 million years ago. Being relatively small, adaptable animals, the coelophysoids survived the extinction event at the end of the Triassic, but were slowly outgunned by larger, more derived theropods that emerged during the early Jurassic, such as Cryolophosaurus and one of my personal favourite dinosaurs, Dilophosaurus, with the group disappearing by about 183 million years ago. However, I'll have to leave the development of the first truly large theropod predators for a future video, with the role of small, fast-running carnivore passing to members of Coelurosauria and Ceratosauria. Thanks for watching, everyone. The next video will be covering more non-avian dinosaurs, in this case being the early relatives of the hadrosaurs within the clade Dryomorpha, which are not often talked about due to misconceptions of them being plain, quote-unquote, boring animals. Feel free to support me on Patreon to propose your own ideas for future videos, and I'll see you again soon. Cheerio.